Now we're going to talk about something called permutations and factorials. Now we'll start with a few definitions. Arrangements is an order of list items. Factorial is a product of sequential natural numbers in the form of n factorial equals n times n minus 1 times n minus 2. Now if you're not sure what this means, by the way, n exclamation mark is read n factorial. Okay? So let's take a look at this right there for a second before we move forward. Let's say we have n factorial. Let's give an example. 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. And now let's relate it back to this equation here, which is n times n minus 1 times n minus 2 times n minus 3, and the sequence keeps going until I hit times 2 times 1. Now if n equals 9, well, that becomes, that becomes 9 factorial. So we can write 9 factorial is equal to 9. What's n minus 1? 9 minus 1 is 8. N minus 2 is 7 times 6 all the way to 2 and 1. Hope that makes some sense and it wasn't too messy. Okay? So that's what that means. Now a permutation is an arrangement of n distinct items with a definite order. So the total number of these permutations is written PNN. And we'll talk about what that means later, but just write these notations, put a square around it, and we'll investigate more. Okay? So you have 5 marbles. Create a tree diagram to list all possible arrangements of picking 3 marbles in a row. So we have an arrangement of 3 marbles out of the 5. So we're going to say this is blue, purple, red. Actually, I forget what we call it. Blue, purple, red. I think I called it K because P was taken for pink. And then green. So we have 3 trials. Our first scenario, we had 5 possibilities. And then after we pick 1, we have 4 left. Notice there's no B in these. And our next, each one of these, there's 3 possibilities. And then we stop. We don't continue to choose. Now, how many different outcomes are there? Well, due to the fundamental counting principle, we knew we had 5 in that situation. And here we had 4. And then to get to the end of the path, we have 3 possibilities. So there's 60 possible outcomes, which is 5 times 4 times 3. So it's multiplied in descending order. And we talked about this earlier. Okay, so I just want you to get comfortable with your calculator first. And I want you to find this factorial button. It's basically a button. It could say n factorial or it could just say factorial. You might have to push the shift key depending on what kind of calculator you have. So just find the factorial button, and 3 factorial is basically equal to 3 times 2 times 1, which is 6, right? So when you put in the calculator, check to make sure you get an answer of 6. Check 10 factorial, you should get a value of this. If you get a value of this, you probably know what you're doing. And now enter into your calculator 10 factorial over 3 factorial. Now that's what that's equal to. Now we can cross out this 3 times 2 times 1 because it's all multiplication and division. But you should get 604,800. But essentially, this is how you would write out 10 factorial. 10 all the way to 1, 3 all the way to 1, and then you could cross out, the common multiples or the common divisors. Likewise for this, okay, put this into your calculator. You're going to end up getting 1. And the way this works is you write, this is 6 factorial, 6 times 5 all the way to 1, 3 factorial right there, and 5 factorial right over here. Okay, I'm going to clear this. So I believe I did that. And if you look here, this 5, 4, 3, 2, 1 can be canceled out against each other. And now you are left with the 6, but then you have 3 times 2, which is the same thing as 6. and it gets crossed out, and you end up with a value of 1. And if your calculator gives that, then you know you're using your calculator correctly as well. All right, let's talk about permutations. And this has to do with that earlier marble question. So when an arrangement of items need to appear in order, it is called a permutation. Needs to appear in order. There are n ways to select the first item, n minus 1 ways to select the second, n minus 2 ways to select the third item, excuse that, and basically eventually 1 way to choose the last item. So the formula, then using the fundamental counting principle, there are n factorial permutations of n items. So you write that as p n choose n equals n factorial. Don't worry about this for now. Really, I should use this on a different slide, but it is true. Just write it down for further use. So let's put this in action. I want to put 7 people, or seat 7 people in a row. How many different arrangements are there? Well, since I want to arrange all 7 individuals, I will use factorial, right? And the way we did that earlier with blocks was we drew 7, 1, 2, 3, 4, 5, 6, and 7. And we knew we had 7 choices for the first. Once one person was sitting down, we had 1 less person, then 1 less person, etc., etc., etc. And that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, eventually, we'll just write that down as 7 factorial to represent that, which is 5,040. So there are we already did it in this manner. There are 7 factorial ways, or 5,040 ways to arrange 7 people in a row. Okay, here's another example of a question that I might ask. There are 12 players on a track team. Only 4 can participate in a relay race. In a relay race, players run in order. So how many ways can you arrange 4 people? Well, the first person, I have 12 people to choose from. The second person, I have 11 people to choose from. Then 10, then 9. So it's almost like 12 factorial, but we stop at 9. Now, this is where permutation notation comes in handy. I'm going to go ahead and... So the position can be filled in 11,880 ways. So I want to do this with using factorials. Okay, and it's kind of a roundabout way. So you'll see where we kind of count more than we need to, and then we subtract. Okay, the number of ways to arrange 12 players is 12 factorials. So imagine we had 12 spaces, but that includes distinct arrangements of 8 non-participants. So take a look at this. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so think about this. There's 12 choices here. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now we have this 12 factorial. That's 12 factorial. It includes this many ways to arrange non-participants, right? So essentially, for every one of these, I have this many ways of arranging the non-participants, right? For every single one. So let's say let's call these players A, B, C, D. Then I have E, F, G, H, I, etc. So these guys can be arranged in 8 factorial ways. For every single way, I can pick A, B, C, D. So what we do is, there's 8 factorial ways, but you don't care about the 8 factorial arrangements of the non-participants. So we divide, right? Because every single one of them, I have 8 factorial ways that I don't care about. So what do? We cross out that. And we end up with 12 times 11 times, whoops, there we go, 9, which is 11,880. Now there's a term for that. This is where P comes in handy, okay? PRN, which means I have N, choose R type. Now, I would memorize this formula right here, which means if I have P, like the previous example, 12 choose 8 is equal to 12 factorial over 12 minus 8 factorial, which means, oops, that's not true. We're choosing 4 out of the 12, right? 12 minus 4 factorial, which is equal to 12 factorial over 8 factorial, which is equal to 12 times 11 times 10 times 9. Later on, you might need to use this formula, which is, what does that mean? It just tells you where to stop, right? P R just tells you where to stop. It's multiplied by n, then take away 1, take away 2, but stop at n minus r plus 1. So let's take a look at that. So if n equals, let's say n equals 12, and we're choosing 4, then what does n minus r plus 1 equal to? Well, that's equal to 12 minus 4 plus 1, which is equal to, what's 12 minus 4? 8 plus 1 is 9, right? So that's my last term. That there is my last term. So what does that equal to? It equals to 12. Oops. It's equal, if we have 12, choose 4, right? N is 12, R is 4. Then we have 12 times 11 times 10. And when do we stop? We stop at this value, times 9. And that's what that refers to. Okay, so let's apply the formula. Oh, we did that already in the previous slide, but here it is again. 12 choose 4. We have 12 factorial over 12 minus 4 factorial. And we have 12 factorial over 8 factorial, which is 12 times 11 times 10 times 9, which is 11,880, which is the exact same thing as we did in the previous example of the relay race. So example 4, 6 team photos are hanging outside the wall of the school gym. 2 are photos of the junior and senior football teams. How many ways can you arrange the photos if the football team photo must be side by side? Okay, so now we're arranging all of them, except we have 6 team photos. Right? 1, 2, 3, 4, 5, 6. Except senior and junior, this is not acceptable. Senior football and junior football, they have to be side by side. So it's actually, if you consider it, in this type of example, this is actually, we can consider this. Let's erase what we don't need. We consider junior and senior football players being beside each other as one item. And so, there's actually only, without the restriction, there would be 6 factorial ways. But if we consider the 2 football pictures as one spot in our arrangement, then we only have 5 spots. In which case, we have 5 times 4 times 3 times 2 times 1. Except, remember when we said this is SF, and this is JF, junior football and senior football. For every one of those, what happened? For every one of these arrangements, I could also have JF, SF. Right? So we multiply that by 2 factorial ways. Why 2 factorial ways? Well, if you think about it, why not just 2? Well, 2 factorial is 2, but the reason why we say 2 factorial ways is, let's say we had a junior football, senior football, and let's just call it a middle football, right? And we said they had to be with each other. They'd all count as 1, but how many ways are there to arrange this? 3 factorial within within that grouping, there's 3 factorial ways to arrange those. So that's why we say 2 factorial. So we multiply 5 factorial, right? For every possible way to arrange these 5, right? This could be SJ, etc. This could be any photo. There are 2 factorial ways to arrange the junior and senior football team. Further explanation. So in case you didn't get it the first time, let's say the 2 football picks are in the first spot, right? I could have, let's say, A, B, C, D represent other sports pictures. Well, I have for A, B, C, D, I also have SJ. Okay? Even further explanation that we talked about earlier about the 3 football picks, there would be 3 factorial ways. So let's just say I had S, J, S, M. These are all the same right here. But these are the ways for every, this is just one of the ways to arrange these. Okay? But for every one of them, I have 3 factorial ways, which is 6 ways to arrange them. All right, this is your homework, text page, question numbers.